Assalamu alaikum, dear students. Today's topic is about uniform circular motion. We are doing unit number 3, dynamics, and this is the last topic which we are discussing today. We come across many things in our daily life that are moving in circular path, and you have also studied the circular motion in the previous unit. The motion of any object in a circle is known as circular motion, or whenever something is moving in a circular path or a circular orbit, then its motion is known as circular motion. But today we will be discussing the uniform circular motion in detail. So let's start the topic. So I will start my topic with a very simple example. As you can see in this figure, that take a small stone and tie that stone with one end of a string, okay, and hold the other end of the string in your hand. Now start rotating the stone holding the string. Like this is your hand and you are rotating that string, and the stone is moving in the circular orbit, okay. The motion of the stone is called as circular motion because the stone is moving in a circular path. In the same way, there are some other examples of circular motion. For example, motion of the moon around the earth is circular motion. Motion of the earth around the sun is the circular motion. So what do we conclude? That the motion of an object in a circular path is known as circular motion. Yes, this is the definition. You can see what is a circular motion. The motion of an object in a circular path is called circular motion. Okay. Now these are the examples. Circular motion of earth around the sun. You can see the earth. This is the blue color circle is showing earth that is moving, that is circulating in this circular orbit. So the motion of earth around the sun is also known as circular motion. Now, this is a frame of reference which we draw on the paper when we want to show the directions on paper. This is showing east, this is west, this is north, and this is south. The frame of reference is when we want to show the directions on paper, we draw two mutually perpendicular lines. Now, circular path is shown, and this is showing the direction is changing at every instant in a circle. For example, you are driving your car or you are riding a bicycle on this circular track. When you are here, you are in east, you are moving to this part, now you reached here, this is north, starting from north. Now at every instant you can see the direction is changing. Now you are in the west direction, then you are going in the southwest, and then this is south. So this figure is showing that in circular path, or whenever you are moving in a circle, the direction is changing all the time. And you know that if direction is changing and the speed is same or the velocity is same but the direction is changing every instant, we say that an acceleration has been produced in the body. For producing acceleration, either a change in direction is required or a change in speed or velocity is needed. But here the change is not in speed, as the car or any object is moving in with a constant velocity, but you can see the direction is changing. Okay, so what do we conclude from this? That whenever we are moving or anything is moving in circular path, the direction is changing at every instant. Okay, now the centripetal force, that is a force which keeps a body moving in a circle. Centripetal force is a force that keeps a body moving in a circle. As you have just read that whenever the body is moving in a circular path, an acceleration is produced in it. And according to Newton's second law of motion, for the producing acceleration, there must be some force. So which force is that? What's the name of that force which is producing this acceleration? So this is Fc. F for force and C for centripetal. Centri means towards the center. Centri is from center and petal means seeking. So centripetal force is center seeking force. Its direction is always towards the center of the circle. And it's that force which keeps a body moving in a circle. And it is represented by, yes, Fc. And as it is a force, so its unit is also Newton. Okay. Now this is the formula for centripetal acceleration that is produced due to the centripetal force. The centripetal acceleration is produced due to centripetal force. And you know that the direction of force and always and acceleration is always same. So if the direction of centripetal force is towards the center of the circle, then the direction of centripetal acceleration is also towards the center of the circle. Now consider a body which is having a mass m, and consider a body which is having a mass m and its velocity is v, and it is moving in a circular orbit, and the radius of that circle is represented by r. Then the centripetal acceleration that is produced by centripetal force, its formula is given by AC, A for acceleration and C for centripetal. AC is equals to square of the velocity divided by radius of the circle. Now, according to second law of motion, the formula of force is F is equals to ma. Now, as I have told you that this is centripetal force, so you will put a C here for centripetal, and for acceleration, you will put a C here. So, Fc is equals to mac. Now, in the above formula, you have seen that AC is equals to V square over R. So instead of AC, I will put V square over R. Now, this is the equation for finding the magnitude of centripetal force. What's the formula for finding centripetal force? That is equal to the product of mass, the square of velocity, and divided by the radius of the circle. We come to know from this formula that centripetal force depends upon three things. One is the mass, second is the velocity, and third is the radius of the circle. Okay. So this is the formula for finding the magnitude of centripetal force. Now the direction of centripetal force. As I have told you that what is centripetal acceleration? When a body is moving in a circular path, its acceleration is known as centripetal acceleration. And this centripetal acceleration is the result of centripetal force. Now, centripetal force always acts perpendicular at an angle of 90 degree to the motion of the body. Now let's consider that the body is moving and this is the direction of motion. This is shown by V, and F is the centripetal force whose direction is inside of the circle. So F and V, the centripetal force and the motion of the body, they are always making an angle of 90 degree at every instant of the circle. Wherever the moving thing is present in the circle, at any point in the circle, F and V are perpendicular to each other. It means making an angle of 90 degree. Okay. Then is again this figure is shown here, and a new force which is the reaction force of centripetal force. According to Newton's third law of motion, if centripetal force is the action force, then centrifugal force is the reaction force. Okay. In the example, in which the first example which I have given you, in which a stone was tied to the string, in that the centripetal force to the stone is provided by the tension in the string. The tension was present in the string when it was tied with the stone, and the centripetal force is provided by the tension in the string. And this centripetal force is the action force. And according to Newton's third law of motion, if there is some action force, there must be a reaction force, and that is known as centrifugal force. If centripetal force is equals to 10 Newton, then centrifugal force, that is the center fleeing force away from the center of the circle, that is equal to minus 10 Newton. And the minus sign shows that the direction of centripetal and centrifugal force are opposite to each other. Okay, and this is the path of inertia, because the direction of motion, uh, whenever you can see, you can observe while performing this simple experiment that if your string breaks at this point, where the stone will go, it will go in the path of inertia, because this is the direction of motion. And according to the property of inertia, a moving thing tends to move in the same, you can say, direction with uniform velocity. So if the string is broken from this point, the stone will go at this point in the direction of motion. Now this is the roller coaster. The roller coaster is showing the example of centripetal force. The centripetal force to this roller coaster is provided by the friction between the wheels of the coaster and the track. Okay. Now the banking of roads, this is an example, this is a practical application of centripetal force, and a very important question from exams point of view. What is the meaning of banking of roads? Banking of road is when the outer edge of the road is raised. You know, when going in the mountain areas or in northern areas where the roads are slippery most of the time, then the friction which is providing the centripetal force, that becomes less, and a car could slip or it could skid from its path. Then this is the banking of road. In banking of road, one part of the one edge of the road is raised. Okay, so to avoid skidding, to avoid any accident, this road is elevated, or its one part is raised up to make the driving safe. Okay, this topic is given on page number 79 of your book. Then how a car moves and stops because of the frictional force that is present between the wheels and the ground, and the road, wheels and the road. This car is moving on a circular track, and this is the direction of centripetal force, and the centripetal force is provided by the force of friction. Okay. Now, this is another example of the application, practical application of centripetal force. This is the spinner or the dryer of a washing machine. You can see that is a basket spinner. This topic is given on page number 79 of your book. And the inside of the spinner, you can see that there is a perforated cylinder. Perforated means having different holes in it, and when the cylindrical lid is closed and the cloths are piled up in it, and this the spinner spins at high speed, but what happens in it, the lack of centripetal force is done. Because of this lack of centripetal force, water goes out of the spinner through the holes, because water is heavy, and cloths, the dry cloths, are piled up in the center. The water goes out because of the lack of centripetal force. Then is a cream separator or a centrifuge. This is a centrifuge. You can see the centrifuge is used in the laboratories to separate the heavy and lighter particles. This is the example of a centrifugal device. and it separates the milk and cream and makes the skimmed milk. The bowl spins at very high speed, and when it moves at very high speed, what happens? The lighter part, which is cream, is pushed towards the center of the bowl, and from where it is collected through the pipe, and the milk is separated at the sides because that is heavy. Okay. Again, in this example, the centripetal and centrifugal forces, the directions of centripetal and centrifugal forces are shown. Centripetal force direction is inside of the circle, and centrifugal force direction is outside of the circle. This is the centrifuge machine, which I've told you that is used to separate the heavy and lighter particles from the mixture of from the mixture of particles in which heavy and lighter particles are present. The lighter particles are collected in the center and heavy particles are collected at the sides of the container of the centrifuge. Okay. In this, the centrifugal force is shown. Yes, this is the centrifugal force. This is the centripetal force, which is inside of the circle. And this is showing the direction of motion or the path of inertia. Okay. So the centrifugal force definition is a force arising from the body's inertia, which appears to act on a body moving in a circular path and is directed away from the center around which the body is moving. And centrifugal force equation is again F is equals to mv square over r, but we will put a minus sign here. Okay, m is the mass of the object, v square is the square of velocity, and r is the radius of circle, and F is expressed in Newton because F is a force. Centripetal as well as centrifugal are the forces. So students, today we have completed unit number 3, and we have completed the topic uniform circular motion. Okay. And in the next class, we will do the exercise.